Welcome back with another tutorial of the exponential decay of an inductor resistor circuit. In this example, they give us in a time 0 second, the current is in one position and has a resistance only of 100 ohms of a voltage of 10. So if we take this information, we can just put it on paper so we know what we are dealing with. So 10 volts, and we have a resistance of 100 ohms. And if we count the total resistance is 200 ohms because they are in series, and we have an inductor of 0.002 Henry. So they are asking us what is current? What is the current? What is the current at a time of 5 microsecond? So we can use the formula of a decay, and we can come up of what is the initial current before the switch goes to B. So we will know what is the current, and then we can find the current, the final current. So I'll give you, this is a formula that we're going to use for the decay, and that's current equal initial current multiplied by the exponential of minus time divided by the constant tau, and tau is equal Henry divided by resistance. So the initial current, we can find it by voltage divided by the resistance. So the voltage is 10 divided by 100 ohms. So the initial current is equal to 0.1 amp. So here, current is equal 0.1 multiplied by the exponential of minus 5 of the minus 5 microsecond divided by tau. So this one is going to be equal to Henry, that's 0.002 divided by resistance, the total resistance. So tau is equal to 200. That's 110 microsecond. So this one is divided by 10 microsecond. So the current, the final current is equal to 0.061 amp. Question number B, they say at what time the current decay at 1% of the current. So 1% of the current, we're going to multiply by 0.1 amp, and this one is equal to 0.01 amp. This is the current. The initial current, actually. So we can reuse this formula of exponential decay multiplied by initial current, exponential of minus t divided by tau. So the final current is 0.1 multiplied by the initial current, that's 0.01 exponential of minus, that's what we're looking for, of the time divided by 10 microsecond. So the time when 1% of the current is decay is equal 46 times 10 power of minus 6 second.